Hello students, I welcome you all in the 9th lecture of the TOC, and we have seen that in last lecture we have started the push down automata, and basically push down automata is a machine which accept the context free languages. And before starting this lecture I will just review what exactly we have covered in the last lecture. So we have started from the concept why we need a push down automata, and we have seen that basically the finite automata that like DFA, NFA, epsilon NFA doesn't have the memory, and in order to accept the context free languages we require an memory, and that memory is available with push down automata. So that's why we have started the push down automata, and we have seen that the push down automata is having the memory, and push down automata is nothing but finite automata plus stack is one memory. Okay, so by using stack what we will do, we can do the comparison of zeros and ones, or we can say that number of A's and number of B's, we can do comparison, means we have something to store the data. Okay, basically finite automata will not remember anything, but finite automata plus stack will have the data what he have previously read from the string. Okay, we can say like that. And then we came across the formal definition of PDA, and we have seen that it is having 7 tuples. Basically all the tuples available in the DFA are same in the PDA also, but we have extra 2 tuples that we have seen that is tau, that is we can say that stack alphabet, stack bottom of the stack, and that is Z0, and we are also having the another alphabet that is known as, so one symbol basically that is Z0 is the bottom of the stack, and another one is tau, that is the stack alphabet. Apart from the Z0, whatever the top of the stack, or we can say that what we have to write after taking an input, and similarly stack alphabet, what is we are going to write on the top of the stack, that is stack alphabet. Okay, so we have covered till now, and also we have seen that there are 2 types of acceptance available. One is we can accept the strings with the final state, or we can accept by using empty stack. In empty stack what we will do, we will remove that Z0 also, that is the bottom of the stack. Also we have covered, or we have came across that DFA is divided into 2 types, that is deterministic PDA is divided into 2 types, that is deterministic PDA and non-deterministic PDA. Okay, and finally we have seen that basically we have 2 types of acceptance, language acceptance, that is string accept and language accept, but we need to design a PDA in such a way that it will accept a language accept. It should be a language accept, because language accept all the languages, all the strings present in the languages. Apart from that, it will reject all other strings which are not present in the languages. But string accept, what will do, what it will do, actually string accept all the strings present in the language, that is only things, but we cannot say that it should reject all other strings. Okay, so our finite automata or PDA should be language accept. Okay, and we have also covered one example, that is the very famous example 0 to the power n, 1 to the power n, where n is greater than or equal to 1. In that example we have seen that this example or this language should not be accepted by finite automata. We have designed finite automata, but we have seen that there will be some problems, and after that we came across the PDA. We have used stack and we have solved that example, and we have designed the PDA for that example. Now what we will do, we will see more examples, so that the PDA designing will be clear. So let's take the next example. So this is the example. Construct a PDA which accept set of all the strings which has number of zeros, in yes. Yes क्या है, एक string है, equals to the number of ones in yes. Okay, so we can say that yes is such that number of zeros in yes is equal to number of ones in yes. तो इसका सोल्यूशन क्या होगा, इसमें क्या है बेसिकली जितने नंबर ऑफ जीरोस होंगे उतने नंबर ऑफ वंस होंगे. ओके, जितने नंबर ऑफ जीरोस आएंगे स्ट्रिंग में उतने ही नंबर ऑफ वंस आएंगे. सो दैट earlier we have seen that 0 to the power n, 1 to the power n, where n is greater than or equal to 1. But in this example and in this example, what is difference? In this example, yesterday we have solved this example, and in that we have seen that zeros should be come first. After that, 1 will start. Okay, there will be one condition: zeros come will have to come first, and after that only 1 will start. But in this, the language becomes, it may be starting with 0 and ending with 1, or it should start with 1 and ending with 0. Only condition is what? Number of zeros in yes is equal to क्या होना चाहिए? Number of ones in yes. So 0 कितना है यहाँ पे? 1 है. यहाँ पे 1 कितना है? 1 है. यहाँ पे 1 कितना है? 1 है. 0 कितना है? 1 है. So that should come in any order, but that should be equal. So what will be the possible strings? 0 0 1 1, then 1 0 1 0, or 0 1 0 1, and we can say that 0 1 1 0 or 1 0 0 1. So the strings will be infinite. Okay, the language contain infinite number of strings. So we have to build the logic for this. So how should we build the logic? Basically, in last example, what we did actually, for 0 we have pushed, and for ones, whenever 1 started, we have started popping. Okay, but in this case it should not be happen, because why? See, suppose I will take this string 0 0 1 1. So 0 0 1 1. Now in this situation, what I have to do? See, bottom of the stack is z0, and whenever 0 comes, I have to push it. So I am pushing it. Okay, so I will write here, whenever 0 come, I will push. 0 आएगा तो push करेंगे, and whenever 1 started coming, I will start popping. So 1 for pop. So 1 started occurring, I will pop it. 1 started occurring, I will pop it. Okay, so this is about 0 0 1 1 string. But take this one string. Okay, so I will take 0 0 1 1 0. Okay, so I will take this one 0 1 0 1, and this is finally epsilon. Now in this situation, what we have to do? See, bottom of the stack z0, and whenever 0 comes, okay, 0 came, I will push it, and once 1 occurred, I will pop it. So 0 for push and 1 for pop. Okay, again 0 came, so again I will push that 0, and again by using this one I will pop it. Okay, by using this one I will pop it. So this is the situation. Up to this it is fine, but suppose this string came 0 1 1 0, and finally this is epsilon. Now what is our logic? Our logic should be bottom of the stack z0, and whenever 0 comes, what we are doing? Okay, so I will push it, and whenever 1 came, I started popping. So 1 came, I popped it. Okay, now again top of the stack is what? Or we can say that bottom becomes now top. Okay, so top of the stack is z0, and 1 occurred. So what should we do? Now I will write here, so it will be clear. इस 0 के लिए हमने क्या किया? पुश किया. इसके लिए क्या किया? पॉप किया. Now if the top of the stack is z0 and 1 occurred or 0 occurred, then what we have to do? We have to push for 0 now. Sorry, push for 1. So I have pushed 1. and whenever opposite symbol come, opposite alphabet come, then I will pop for that. So यहाँ पे क्या किया है मैंने 1 के लिए push किया है. Then now what I will do for 0? I will pop it. So whenever 0 occurred, I have popped this one. Now it becomes 0. तो यहाँ पे लॉजिक क्या है कि whenever सेम सिंबल ऑकर होते रहेंगे, जब तक सेम सिंबल ऑकर होते रहेंगे हम क्या करेंगे, पुश करते रहेंगे, वेदर इट विल बी 0 or 1, that doesn't matter to us. Whenever opposite symbol comes or opposite alphabet comes, then what we will do, we will start pop. Okay, I hope it is clear. Now our work is to design a PDA. So let's design a PDA for this. Now I am in Q naught state. This is the initial state. Okay, so basically in Q naught what I will do, so bottom of the stack becomes, so this is the stack, this is Z naught. Okay, so bottom of the stack is Z naught. What I will do, suppose I will take a one string like 0 0 1 1 and this is epsilon. 0 came, so if the top of the stack becomes Z naught, so I will use 0 Z naught. Similarly again 0 came, then what I will do, 0 0, it will become 0 0. Okay, but what if the string is like this, 1 1 0 0 epsilon? For this string, what will be the position of the stack? Initially stack is at Z naught. Okay, top of the stack is Z naught and input alphabet is 1. So 1 on Z naught, what we will do, we will push it. So 1 on Z naught becomes 1 Z naught, and again 1 occurred, so same symbol, because top of the stack is having now 1 and this is matching with the input, then this is input and this is the top of the stack, then we will push that symbol into the stack. Okay, so this is the condition. But what if, now what if again we have discussed, okay, this is now for push, okay, this is now for push, but we have discussed this condition, 0 यहाँ पे क्या हुआ था, 0 आया था तो we have pushed and opposite symbol आया तो we have popped. Again 1 आ गया तो हम क्या कर रहे हैं, push कर रहे हैं. So we will not do, we will not change the state. What we will do here only, यहाँ पे अगर 0 आता है and top of the stack क्या है, 1 है, then we will do the pop. Okay, 0 and top of the stack क्या है, 1 है. So basically this is the string 1 1. Just a second. So consider this 1 1 okay, 1 0 1 0 epsilon. Okay, so this is the string. So basically I am, for this one I have pushed into the stack, and once 0 came, what I will do, okay, so 0 came, I popped it. Now next work, again 1 came, and if for popping, if I have been changed the state, then again I have to write the same transition there. So that's why I am not changing the state. So 0 आ गया, 1 आ गया, then I have popped, again 1 आ गया, then I will use, and bottom of the stack क्या है now, top of the stack becomes Z naught. So 1 on Z naught, what I have to do, I have to push it, because now stack contains nothing, so because of that I am staying in this state only. And now for opposite also, if 1 is the input symbol and top of the stack is 0, then also we are doing the popping. Okay, and finally our string is over and we are left with only this epsilon. So we will write here epsilon on, now top of the stack becomes Z naught, so we will keep that Z naught as it is, and we will move to the final state, that is QF, if we are accepting it by using the final state. Otherwise we will end up in this state only. Okay, that is by empty stack. Okay, I hope you have cleared about this example. Let's move to the another one. So the example is we have to construct a PDA for the language L is equal to 0 to the power n, 1 to the power n, and 2 to the power m, where m comma n is greater than or equal to 0. So first of all, I will write the language for this. Okay, means I will write some strings. So minimum length string becomes 0, 1, 2 when m comma n both are equal, that is equal to 1. The next string possible is 0, 0, 1, 1, 2 because 0 and 1 having the same power, that is n, means whatever number of zeros, that number of ones should occur. So 0, 0, 1, 1, 2, again 0, 0, 0, 1, 1, 2, otherwise 0, 1, 2, 2, 2, 2, okay, 0, 1, 2, 2, okay, and the string contains infinite number, the language contains infinite number of such strings. Okay, so basically we have understood one thing from here, from this example, that is 0 and 1 are equal, so we can compare 0 and 1. Okay, we cannot compare 0 with 2 or 1 with 2, we can compare only 0 and 1. So what we will do, so for this example we will build a logic like this. For 0 we will push, for 1 we will pop it, and for 2, whenever 2 started occurring, we will just read it. We will not do any operation or no operation in the stack. Okay, I hope आपको ये logic समझ में आ गया होगा. Now our work is to design a PDA. So I will take stack here. Just a second. So this is the stack, and bottom of the stack is Z, and we will take one string also, that is 0, 0, 1, 1, 2, and finally this is the epsilon. Okay, now my pointer is here and stack pointer is here, and initially I am in Q0 state. This is the starting state. We have to mark this arrow because it indicates the starting state. Now for 0 we have to push, and for whenever 1 started occurring we have to pop. Now for 0, what I will do, initially 0 occurred and top of the stack is Z0, so I will write 0 Z0, I have to push that 0, so it will become 0 Z0, so I have pushed. Now top of the stack becomes this 0 and I moved to this input. Now again 0 occurred and top of the stack is 0, so what I will do, so 0 occurred and top of the stack is 0, so again I have to push that 0 into the stack. So I have pushed that 0 into the stack and I have changed my top pointer, and similarly I have moved to the next input. Now I came to 1, and we know that for 1 we have to pop the things. So whenever I have to pop, I will change the state, because what happen if I will not change the state? If I will do the same operation in this state, and if after 1, 1 suppose 0 comes, again it will do this operation, and because the language doesn't contain this string, that is 0, 0, 1, 1, 0, 2, the language doesn't contain this string. But if I will do popping operation in the same state, then this string will be accepted, so we don't want that. Okay, we want to accept only the strings which are present in the language, and similarly we have to reject all the strings which are not present in the language. So this language is not present in the language, we have to reject it. So that's why I am going to change the state. So I am moving to the next state, and here 1 occurred and top of the stack is 0, so I will do the popping. So for this 1 occurred, now I have changed the state into Q1. Okay, so I went to the Q1 and this 0 is eliminated for this 1, and my top of the stack becomes this. 1, sorry 0. Okay, and I have moved to the next input. So next input is 1 and top of the stack is 0. So for this also I will do the popping 1 0, and here I will do the pop operation. Okay, so this 0 becomes popped because due to this 1. Okay, and finally my top of the stack becomes z0, and my next input is 2. So what I will do, so whenever 2 comes, I will again change the state because of same reason. If I will stay in this state, again 1 0 operation, sorry 1 will be occurred, or that might be the case. So that's why I have to change the state. So here 2 and top of the stack is z0, so I will do nothing in the stack. I will make as it is z0 and I will change the state. Okay, so I will move to the QF state, final state, and whenever 2 comes, I will make it z0 and I will not write anything in the stack. So this is the PDA for the language 0 to the power n, 1 to the power n, 2 to the power n. Okay, let's see the another example. So we have to construct the PDF for the language L is equal to 0 to the power n, 1 to the power m, and 2 to the power n. So similarly, like previous example, we will write the language, means we will write some strings possible over this language. Here 0 to the power n and 2 to the power n are same, means whatever number of zeros, that number of 2's should be there. Okay, so the language contains 0 1 2, this is the minimum length language, so minimum length string, then 0 0 1 2 2, then 0 0 1 1 or 1 1 or 4 times 1, and this 2 2 2 2, sorry here should be 4 zeros then. Okay, then again 0 0 1 1 1 1 1 1 2 2. Okay, so now we have understood that 0 and 2 are dependent and 1 are independent, means 1 is independent of 0 and 2. Okay, so we can compare 0 and 2. So what we will do, for 0 we will push it, and for 2 we will pop, and for 2, sorry for 1 we will do nothing, that is no operation, we will just read it. So directly I will start designing the PDA. So whenever 0 comes, I will have to push it. So 0 and bottom of the stack, okay, I will draw the stack also. So bottom of the stack is z0, and I will take 0 0 1 1 1 2 2. Okay, and finally epsilon is there. This is the top of the stack, we can say that, and this is the input alphabet. So 0 and 0 on sorry 0 and top of the stack is z0. So what we will do, we will push that 0 into the stack. So I have pushed this 0 into the stack, and I have moved the top pointer of stack to the 0. So again I have the input 0 and top of the stack becomes now 0. So what I will do, I will push that 0 into the stack, so it will become 0 0. Okay, similarly now by doing this we have, or we can push all the zeros in the stack. Okay, now next what we have to do, 1 occurred, and for 1 we have to do no operation, but we will change the state because there might be possibility to get 0 after 1, and if we will stay in particular state only and after 1 suppose 0 occurred, then again we will do the same operation, that will create a problem, that will accept the strings like 0 0 1 1 0 1 0 2 2, like these strings, but we have to reject such type of strings. So for that, once input is 1 and top of the stack is 0, so I will do nothing, that is I will put 0 as it is. So that 0 is as it is. I will not do any operation and I will move into the Q1 state. Now again I have came across to one input on top of the stack is 0, so I will do for all ones on top of the stack is 0, then I will put 0 as it is. I will not do any operation for this one also. Now 2 occurred, so top of the stack is, so this 0 is also pushed, this one. Now this 2 occurs and top of the stack is 0, then what I will do, I will first change the state and I will do the operation popping. So 2 occurred and top of the stack becomes 0, I will start popping. So 2 and top of the stack is 0, sorry, top of the stack is 0, so I will do popping. So I have popped that 0 for this 2. I moved to the top pointer of the stack becomes next 0. Okay, and here in this state, if I will get more number of 2's, then I will check for whether the stack contains 0. If stack contains 0, then I will start popping it. And finally, if I will come across to the epsilon and top of the stack becomes z0, I will put that z0 as it is and I will move to the final state. Okay, so this way we will accept all the strings present in this language, and we should, in same way, we should not accept or we can reject all other strings which are not present in particular this language. So we can say that this is the PDA for this language. Let's move to the another example. So this is the example. We have to construct a PDA for the language 0 to the power n plus n, 1 to the power n, 2 to the power n, where n comma n is greater than or equal to 0. So same language should be written like this. So language becomes 0 to the power m, 0 to the power n, 1 to the power m, and 2 to the power n. Okay, and similarly this can be rewritten like this. So this will become 0 to the power n, 0 to the power m, 1 to the power m, and 2 to the power n. Okay, these both are correct because whether we can write 0 to the power m, 0 to the power n is equal to the 0 to the power n, 0 to the power m. Okay, now how can we solve this example? Okay, for 0, this 0 we have 2, and for this 0 we have this 1, because whatever number of these zeros will be equal to these ones, and whatever number of these zeros will equal to the these 2's. Okay, so what we will do for this 0, what we will push, and these 0 are compared with these ones, and whenever 2 started occurring, we will start popping these zeros. Similarly, for these zeros, we will start pushing, and whenever this one comes, we will compare with these zeros and we will start popping. Okay, so let's write the language. We will write some strings. So strings possible, suppose this is 2 zeros when n is equal to 2, and this is 0 when m is equal to 1. This 1 becomes 1 only, and number of 2's becomes 2. Okay, then next string will possible will be, suppose n is equal to 1 and m is equal to 2, so this 1 is equal to 2 and this 2. Similarly, this 0 becomes 3, means n is equal to 3, and this m is become 2, so this 2, and finally we can say that this m become 2, and this 2 becomes 3 because n is equal to 3. Okay, so likewise we will get infinite number of strings possible over this language. Okay, so let's design a PDA for this language. Top of the stack, or we can say that bottom of the stack is initially z0, and suppose I am considering this string 0000122. Sorry, 000. Okay, correct. this is n, this is m, this is m, and this is n, and finally epsilon. Okay, so what we will do, first we will push that zeros, so our q naught state becomes whenever my input is 0 and top of the stack is z naught, I will push 0 into the stack, that will become 0 z naught, and I will move top pointer to the 0. Next, again if 0 occurred and top of the stack becomes 0, then again I will push 0 into the stack. So I have pushed the 0 and moved the top pointer to the next. Again next input is 0 and top of the stack is 0, again I will push by using this operation only. So I have pushed this. Next, whenever one started occurring, what I will do, I will change the state and top of the stack is 0, then I will start popping. This is for 1 1, okay, this is for single one. But what if there are lower number of ones, when these zeros m is equal to more than 1? For that situation we will write here, whenever one comes and top of the stack is 0, then we will pop. Okay, now next we have moved to the 2 and top of the stack becomes 0, then also we have to do the popping. So for this 0 I have popped this, for this 2 I have popped this 0. Similarly for this 2 we have to pop this 0. So in Q2 state, what we will do, we will do this operation till the 0 is present. Okay, and whenever 2 started, 2 is occurring. Okay, so for this 2 I have popped this. Now my top of the stack becomes z naught and input is epsilon. So whenever input is epsilon and top of the stack is z naught, तो उसको हम z naught ही रहने देंगे and we will accept the string in the final state. So this is the machine, or we can say that this is the PDA for this particular language. Let's see the another one. So we will see next example. This is also similar to the previous one. So in this, what we will do, we will not write the languages, or we can say that we will not write the strings, we will directly build the logic and we will solve it. So this language will be rewritten as like this: 0 to the power n, 1 to the power. So we have this n and this n, we have to compare, and finally this 1 with this 2. Okay, so 0 to the power n, then I will write 1 to the power n. Similarly 1 to the power m, and this is 2 to the power m. So for this, what we will do, we will push. Whenever 0 comes, we will push. Whenever 1 comes, we will start pop. And whenever the top of the stack becomes z naught and 1 occurred, then what we will do, for this 1 we will push, and by using this 2 we will start popping. Okay, so in this situation, so I will write strings also, because you have to understand this example basically. So the string becomes 0 1 1 2. Okay, whenever m comma n is equal to 2, this 0 0 1 1 1 2. Whenever n is 2 and m is 1, similarly we can say that 0 1 1 1, just a second, 1 1 2 2. Okay, whenever n is equal to 1 and m is equal to 2. Okay, similarly we will get infinite number of strings present in this particular language, and we will make stack also, so that this can be understood easily. So top of the stack is z naught, and I will take the string 0 0 1 1, then 1 1 1 2 2, and finally epsilon. Now I am here. So initially I am in q naught state, and whenever I get an input 0, what I will do? 0 on Z0, I have to push that 0 into the stack. So I have pushed that 0 into the stack and I have updated the top pointer. And similarly, I have moved to the next input. For any number of zeros, I have to push it. So next 0 comes, I will start, and when top of the stack becomes 0, I will start pushing it. Okay, so this will become 0 0, and I have moved the top pointer here and input pointer here. Whenever one started occurring, I have to change the state and I have to do the popping. One is the input symbol and top of the stack is 0, then I have to pop. Similarly, for all number of ones, I will do the same things. So when I came to this 1, and top of the stack becomes okay. So by using this operation, I have popped this 0. Similarly, by next one, and top of the stack becomes this one. So 1 and top of the stack is 0, I will do pop. So I have popped this 0 also, and I have moved to the next top pointer, that is Z0, and I came across for 1. Now observe this, these ones are, or we can say that these ones are over. Now these ones are started. How we have identified? Because for popping we need a 0 in the stack whenever 1 occurs, but there is a no 0 present in the stack, so we can say that number of zeros are equal to the number of ones are over. Now it's time for another ones. So now whenever one started occurring, what we will do? We will do the pushing. So here only we can write, because it will not create any problem. So 1 is input and top of the stack is now Z0. So what I will do? I will push that 1 into the stack. So it will become 1 Z0. Now it will become like this 1, and top pointer is this. Similarly, for another one, 1 is my next, this is 1, and my next 1 occurred, and top of the stack becomes 1, then I will push that 1 also into the stack. Similarly, for third one also we will do the same thing by using this operation itself. So this will become this 1, and top pointer is this. Now once 1 is over and 2 started occurring, what we will do? We will start popping it, because we have to compare this 1 and these 2. Okay, so whenever we need a comparison, we have already pushed the ones. Now we need to check whether that 2's are equal to that pushed ones or not. Okay, so whenever 2 is the input symbol and top of the stack is 1, we will start popping. So I have to start pop this one. So this one is popped, and top pointer becomes now this. So for remaining 2's, for next 2 also we will do the same operation. Whenever 2 is there and 1 is the top of the stack, we will do popping. And finally, for all these 2's, all ones are popped. And finally, if we came across the epsilon and top of the stack is Z0, then we will keep that Z0 as it is, and we will accept in the final state. Okay, so this is the PDA for this particular language. Okay, let's see this example. We have to design a PDA for the language 0 to the power n, 1 to the power m, 2 to the power n plus m. Okay, where m comma n is greater than equal to m comma n is greater than equal to 1. Okay, so language for this becomes 0 to the power n, 1 to the power m, and we need m first. So we will write this 2 to the power m and 2 to the power n. So this and this should be compared, and this one should be compared with these two. Okay, so basically the language contains the strings like 0 1 2 2, or we can say that 0 0 1 2 and this 2 2, or 0 0 1 1 1 2 2 2, and finally these two. Okay, so language contain infinite number of strings possible. Okay, so basically what we need to do, for these zeros we have to push, and whenever one started occurring, again we will push these ones. Okay, for 0 and 1 we are pushing. Now we have to compare these zeros, sorry, these ones with these twos. Okay, so whenever 2 started coming, we will start popping, and now these twos should be compared with these zeros. So for this also we will do the popping. Okay, now so our PDA become, so we are in Q naught state. Okay, and this is the stack, and top of the stack is now Z naught. And suppose this is my string, finally I am adding epsilon. Now I am here. Whenever 0 occurred, I have to push. So 0 is there and top of the stack is Z naught. I will push that 0 into the stack, so it will become 0 Z naught, and I will update the top pointer. Similarly, for other zeros also, 0 is there and top of the stack is 0, then I will push 0 0. So this top pointer is updated and I have moved to here. Now in this situation, whenever 1 also occurred, I have to push only. So when 1 is the input symbol and top of the stack is now 0, 1 and top of the stack is 0, then I have to push that 1 into the stack, so it will become 1 0. So it will become 1 0, and I will update the top pointer and I will move to the next 1. So similarly for that 1 also, 1 is the input and top of the stack is now 1. For that 1 also I have to push it, so this will become 1 1. So this will become 1 1, and I have moved to the top pointer as here. Now again I got 1. So for this one also I will use same production, this production, and I will push that one also into the stack. Okay, now I came across 2. Whenever 2 started occurring, I have to pop, and top of the stack become now 1 is there. So what I will do, I will pop that 1 for 2, and I will move to the next state, that is become Q1. Now I am in this state. Whenever 2, for this 2 I have popped this one. For this 2 I have to pop again 1, so 2 is input and top of the stack is 1, then again I am popping it. So I have popped this one for this particular 2, and for this 2 again I have popped this one. Now see this, again 2 occurred and top of the stack is now 0, but for this 0 also I have to do the popping. So I have to write operation like this, 2 is input, and whenever I got the 0, then also I have to do the popping. So for this 2 also I have popped this 0, and for this 2 I have popped this 0. Now my top pointer becomes Z naught. Okay, my top pointer becomes Z naught and input symbol is epsilon. So epsilon and top of the stack is Z naught. I will make that as Z naught only, and I will move to the final state, and I will accept this string. So this string is accepted by using this PDA, or we can say that all the strings present in the particular language or which are belongs to the particular language will be accepted by using this PDA. Okay, I hope आपको ये example समझ में आ गए होंगे. Okay, some more examples are there. We will see that examples in the next lecture. Thank you so much.